Good morning. So in previous lecture we have seen one of the architecture style, that is data flow style. What are the concurrent statements we can use in the data flow style, and how to implement or how to write using those statements. Uh, already we have seen in the previous lectures. Now coming to another style, that is structural style. What are the design elements in the structural style means? Those are component declaration and component instantiation. The component declaration appears in the declarative part of architecture body, whereas component instantiation is in the statement part. Okay. So in the if the style is structural, the one component declaration is compulsory. That is the component declaration. Okay. So let us see what is the syntax for the component declaration. Previously also we discussed about component declaration. That is, the component declaration is its syntax is similar to entity syntax. Only the difference in terms of entity word, here the word used is component. Component name, that is user defined name, is port of different signals, their mode and their data type. Then end component. See one example for this component declaration. Here is the example for 2 input NAND gate. So start with the word component. Name of the component is NAND2 is. Then port is A comma B colon in bit. That means these two objects are of class signals and their mode is in. Means AB are the inputs to the NAND gate. Okay. How can you say signals? These two are whatever you declare in the component, those are treated as the signals. Similarly, entity declaration also, whatever you declare, they are treated as the signal classes. And the data type is bit. Then, so another object is Z, we declared here. Its direction is, its mode is out, data type is bit. Then end this component declaration by the word end component. Okay. So like that you can write the component declarations for different components which are available in the logic circuit. Okay. Then let us see the syntax for the instantiation statement. It starts with the label name colon component name, then port map association list. Port map to association list. So the example for this is, so here for the same NAND2, the instantiation statement is start with the label name, that is label name here is N1. N1 is the label name colon component name. Already in the component declaration we have given name as NAND2. The same name you have to use here also, NAND2 followed by port map of association list. Association list is compulsory follow the order in which the signals declared in the component declaration. Okay, so that means S1 is input, S2 also input, but S3 is output. Okay, so that is the way you can declare and you can write the instantiation statement. Okay? Actually, in the at the beginning we have seen how to write the structural program for half adder. Okay, so you check once that program and write down a structural program for 4-bit prime number detector and also a full adder using half adders. Okay, so before writing the program, first of all you need to identify what are the different components and how many. What are the different components and how many components? Why? Because the number of component declarations are equal to number of different components, and the number of instantiation statement is equal to the number of components. Okay. Then see another model, that is behavioral model. In the behavioral model, The declarations are dependent. If you need, you can declare, otherwise no. Then coming to statement part, the concurrent statement is process. The concurrent statement is process. Okay. The process statement, see the syntax of process statement. It starts with the word process. Before the process word, you can use or not. That is optional one. Label name. Label name you can put or not. That is it's not compulsory. Then process of sensitivity list. Sensitivity list also optional one. Then declarations. Different declarations are type declarations, variable declarations, constant declarations, function declarations, procedure definitions, function definitions, and loop statements. These are all the declarations. These are all the declarations you can declare in the declarative part of process. Okay. Then the statement part starts. Before the statement part starts, you have to use the word begin. Okay, actually the begin separates declarative area and statement area. Then see here, all the statements in the statement part, the statements are called sequentially executed statements, whereas in the architecture body the statements are called concurrent statements because their execution is simultaneous. Now see what are the different sequential statements are available, like variable assignment statement, signal assignment, wait statement, if statement, case statement, loop statement, null statements, exit, next, procedure call statements, return statements. These are the different types of statements you can use in the statement part of process. These are all the sequential statements. That means their execution is one after another. So finally, the process is ended by the word end process followed by label name. Okay, label name is optional. If you use at the beginning, the same name you have to use here also, otherwise no need. Then see one example program for this behavioral modeling. Here I have written the behavioral model program for AOI gate, that is AND or invert gate. Already in the first chapter we discussed about AOI gate. Its expression is AB plus CD whole bar. AB plus CD whole bar means it has 4 inputs. It has 4 inputs, 1 output. Okay. So the entity of this AOI gate is entity name is AOI is, then port of how many inputs? 4 inputs. Here named as A, B, C, D. Mode is in, data type bit, semicolon. Next only one output. Here I am using its name as Z colon out bit, and entity name, that is entity name is AOI. Okay. Then coming to architecture body, the architecture body in the behavioral model, right? So the syntax of architecture body is, it start with the word architecture name of entity name is, that is the first line. So here architecture name is AOI sequential of, then entity name already previously we have written entity for AOI get with the name AOI is. Then here there is no any declarations, that's why directly I'm writing begin. Then the concurrent statement is process. Okay, process of sensitivity list. Generally the sensitivity list consists all the inputs. Okay, here 4 inputs we have, those are A, B, C, D. Okay, then in the process we have a declaration like variable declaration with the word variable temp1, temp2, data type is bit. Okay, then begin. So in the after begin, in process, this is the begin for process. This is the begin for process begin, whereas this begin is architecture begin. Okay, concurrent state process is the concurrent statement, but the statements of process of the sequential. Okay, so first of all, the statement is temp1 colon equal a and b. Okay, why the symbol colon equal? Because temp1 is a variable. Temp1 is variable assignment symbol is colon equal, and the operation is a and b. Okay, so here an AND operation can be performed on inputs a and b. Then temp2 colon equal c and d. This is another variable assignment statement. Here also AND operation can be performed on the inputs c and d. Okay, then on these two variables temp1 and temp2, you have to apply OR operation that is temp1 equal to colon equal to temp1 or temp2. Okay, then z less than equal not temp1. Okay, here some mistake is there. You take one more variable temp3, so put temp3 equal to temp1 or temp2. Okay, so because the gate is AND or invert, so first you did AND operations. Okay, the result of AND operations are placed in temp1 and temp2, then apply OR operation on temp1 and temp2. Then if you take the negation of temp3, gives final output. Okay, AND or invert, right? Then end process the end, then architectural end. Okay, end architecture name, end process, end architecture name. Like that you can write a program in the behavioral model, right? Okay, now the discussion on what are the syntaxes for different sequential statements. Okay,